Hello, viewers. In this video, we'll be looking at these two questions. The first question is to find the range of this exponential function, f of x equals to 1 minus 2 exponential minus absolute value of x. While the second question is to find the interval where the graph of this exponential function is decreasing. So let's start. Now, for the first question, we need to just to simplify things. If we look at this exponential minus this, this is the same thing as 1 over exponential absolute value of x is the same. And now we can split this into two parts. The first part will be just 1 over e exponential x, and this is when your x is greater or equals to 0 because we have absolute value. And the second one is 1 over e minus x if your x is less than 0. Is that okay? So if we look at this carefully, we can simply rewrite this as what? This one is 1 over e exponential x when x is greater than 0. And this one, you can see it is 1 over e to power minus x. So this will become just e to power x when x is less than 0. Because you have 1 over e. Don't forget, 1 over e is the same thing as e to power minus 1. And then you have to power minus x. So minus 1 minus x becomes ex. So what it means is that this one, e to power minus x, is this much. So to graph, we can start graphing by saying, okay, let's start with the original function here. Now, what is this function? So this is 1 over e. Don't forget, 1 over e now, 1 over e is going to be between 0 and 1 because we know that e is 2 point something, 2.7. So 1 over e, this should be a decreasing graph that cut at 0. Cut at 1 here, right? So this is the graph of 1 over e to power x. But we are only interested in the positive side when x is greater or equals to 0. So it means we have to remove the negative part. So we have to maintain only this one. Yes. Now, this second part is just the exponential ex when x is less than 0. Exponential ex, we know is going to be increasing because the base e is a number greater than 1. So that is going to be something this way. Let's use this for that. So all is going to meet at 0.1. So this one is nothing but ex, and this is 1 over x. Okay. Now, something else is that if you look at this graph, the graph we're looking at, you see there is a 2 behind the function. So there is a 2 behind the function. So it means we have what we call, I think it's a vertical stretching. Yes. And if you remember something in 001, we said if y is equals to f of x, and you also have y is equals to c f of x. So if you have the point xy on the graph of f, then you're going to have the point xcy on the graph of what? Cf of x. So it means that because you have a 2 here, so something is going to happen to the graph. So in other words, this point, remember this point originally here is the point 0, 1. Now, so let me just simplify this point here. So what I'm saying is that if you have the point 0, 1, you see this 0, 1 is on which graph? It's on the graph on the graph of what? Exponential minus x. Yes. So now, because there is a 2 behind it now, here, it means that this point is going to become 0, 2 because of this 2 here. So what it means is that we have to shift this point now up a little. So we're going to take it to 2. So it's no longer be here. So we have to remove this. Then here we are 2. So we're going to have something like this. And this also, we have to move up a little. Okay. So now this is our graph of what? This is, we can add 2 here if you like. From the beginning, you can make the 2 as a coefficient here. Okay, now we have a minus. So what does this minus represent? This minus means that we have to what? We have to reflect across the x-axis. So if this point is 0, 2, it means you are coming to a point now, which is going to be 0 and what? Minus 2. And so it means we're going to have something like this. So this is going to be here also. Don't touch the horizontal. So very close. And here, it will be something like this. Okay. So this graph is nothing but minus what? The whole of this is minus 2 exponential minus x. So I mean both the left hand and the left and the right hand side. Okay, so we can remove this now, the whole of this. Okay, so what next? We now have to what? We have to do vertical translation because we have a 1. So we have to go up 1 unit. Now, if you look at this point here, y equals to 0 is our horizontal asymptote. So if we go 1 unit, it means we will move from minus 2 to where? To minus 1, somewhere here. So it's just going to be something like this. Then this side also will have to go up a little. Okay, it's not peaking yet. All right, good. So we have something like this. So we have to remove this 2 part. But now we can see that our horizontal asymptote is now going to shift up a little. So this will be our horizontal asymptote. Is going to be at y is equals to what? At y is equals to 1. So with this, we can see that, remember, here is minus 1. So what would be the range? So our range is just going to be from minus 1 close, and we will go to 1 open. So this is the range of the function. Now, number 2, find the interval where the graph is what? Is increasing. So let's start with the original graph. So we can start with the graph of 5 to power x, which will be an increasing graph, quoting at 1. Yes, so what else? We shift it a little bit to the right by 3 units. So if this is 0, 1, so we will be somewhere here, which is going to be at 3. So we will have it cut this way. Yes, so this will cut this one. We're going to cut this way first. Then remember, this point is now what? 0. No, this is 3 and 1. This is still 1 here. Okay, then we have to move 1 unit down. So if you move 1 unit down, it means the value of y will decrease. So it will become here. So this is where it's going to be. So finally, we have to cut this part. And let's say we keep going somewhere here, right? Okay. So this is Now, but let's see if x is equals to, if x is equals to 0, we're going to have what? 1 over what? If x is equals to 0, we're going to have 5 minus 3 minus 1. So this is a small number, which will be less than minus 1. Okay, so we know here is going to be less than minus 1. But do we really need that? Now, let's see. Since here, so this will be like the graph of 5x minus 3 minus 1. Okay, now, since we are looking for what? Since we are looking for the uh, the absolute value, we want to take the absolute value of everything. So because of this absolute value, it means we cannot have any part to be less than, to be below the x-axis. So because of that, all you need to do is you have to what? Reflect this number, reflect this left-hand side across the x-axis. So which is just going to be something like this. So this is now, let me use another pen here. Okay. So this is just going to be something like this. So which is the reflection of this part. So we will not have this part. Remember, we said this part will cut somewhere less than minus 1. Yeah, because if you put x equals to 0, I remember you say 5, 3 minus 1. This is a very small number. So it means if you reflect it, it should also cut below what? Below 1. Yeah. So we can remove the whole of this. And this is the graph of the absolute value of 5x minus 1. So since we're looking for the part where this is what? Decreasing. Decreasing means this one. So decreasing is going to be from where? Minus infinity to where? To 3. Remember, increasing, decreasing, we usually leave it open, yeah? So this is going to be decreasing, yeah? So for increasing is going to be, increasing is going to be from where? From 3 to where? To infinity. But since we're asked to find decreasing, then we're done. Okay. Now I hope these questions are clearly solved. If you have a question, you can ask in comment section. Not, that's it. So make sure you like, and if you have not yet subscribed to my channel, please kindly do that and turn on the notification bell. Thank you for watching.